Let's look at the sum of 1 over n and see that it diverges to infinity. So firstly, let's look at Sn. Sn is simply 1 over 1, 1 over 2, 1 over 3, and we just go up to n. So instead of going up to infinity, we're going up to n instead. So now we have S1 is equal to 1, S2 is equal to 1 plus a half, S4, let's ignore S3, let's look at just a part of the sequence. So we're looking at a subsequence instead of the whole sequence and seeing what happens to it. So we have S4 is 1 plus a half plus a third plus a quarter, but we can actually notice that this is more than or equal to 1 plus a half times by 2, because 1 plus a half, but then we also have this. Now a third is more than a quarter, so a third plus a quarter is less than or equal to 1 quarter plus 1 quarter, which is equal to half. So we have S4 is more than equal to 1 plus a half, which is where this has come from, because we have 2 halves now. So in general, if you keep going, you can prove that s to the 2n is equal to 1 plus a half plus a third plus a quarter all the way up to 1 over 2n minus 1 plus 1, 1 over 2n minus 1 plus 2, and then keep going up until you hit this last term, which is 1 over 2n. So if you notice, that's 4, that's 4, that's 2, that's 2. And then, by the same reasoning that's here, you can say that's more than or equal to 1 plus n over 2. So basically, we have a subsequence as 2 to the n, which is more than 1 plus n over 2. And as n becomes infinity, gets larger and larger, this whole thing goes to infinity. So we have found a subsequence of this such that it goes up to infinity. So no matter what the other terms are, we have just a bunch of terms up to infinity basically. So we have proved that some of these parts go up to infinity, and since all the terms are positive, the whole thing must go infinity. So in conclusion, the harmonic series has to go to infinity.